All right, let's wrap up section 1.5. We'll do 1.5b, which are going to be two objectives. We're going to figure out how to solve absolute value equations, and then we're going to take a look at a couple situations of factorable equations. So, up first, let's talk about absolute value equations. And the key to this is that anytime you see an absolute value problem equal to some value a, we're going to split that up into two equations. Whatever's inside the absolute value bars equal to positive a or equal to negative a. And so we're going to have to write this as two separate equations, one positive, one negative, because that's what absolute value means. It means your answer could be positive or negative. So, one example and then one for you to try. X minus 3 equals 2. We're going to take the stuff inside x minus 3, set it equal to 2, then write or x minus 3 equal to negative 2, and just solve from there. Add 3 to both sides, x is equal to 5, or x is equal to negative 2 plus 3, positive 1. Okay, if we checked that, 5 minus 3, the absolute value of that is the absolute value of 2, and that's equal to 2. Story checks out there. If we did the absolute value of 1 minus 3, we would get the absolute value of negative 2, and is that equal to 2? Yes, it is. So, there's your answer, 5 or negative 1. Go ahead and try problem 67, and then we're moving on. Okay, second objective for 1.5b, we're going to solve equations by factoring. So, two things to review here. The first one is anytime you look at the degree, so in this case 3, the biggest exponent you can find, that's how many solutions we're going to have. So we're always going to want to try to get 0 on one side. So let's move that x squared over. Minus x squared on the left. Minus 2x equals 0. And you ask yourself, is there anything in common with all these terms? Yes, there's an x. And then we have x squared minus an x minus a 2. Can I factor that parentheses? What multiplies to 2 subtracts to 1, a negative 2, and a positive 1. And since everything's equal to 0, we can set all of these terms equal to 0. Don't forget the original x. X is equal to 0, x minus 2 is equal to 0, and x plus 1 is equal to 0. So we keep x equal to 0, x is equal to 2, x is equal to negative 1. I have 1, 2, 3 solutions. That's how many I should have had from the beginning. And so I am done. All right, so that's the first type of factoring we need to be able to do, remembering that the degree will always match up with the number of solutions you have. Then we need to remember our old friend factoring by grouping. If we've got a 4-parter, this is a big clue that we're going to factor by grouping. Okay? If we have 4 terms, we're usually going to split them up into 2 sets of 2. So let's take that first set, the x cubed minus the 3x squared. What's in common? X squared. What's left over? X minus 3. All right, minus what's in common? 4. What's left over? X. Now here's where people make mistakes. Since we took this negative outside of new parentheses we formed, this becomes a minus 3, because negative 4 times negative 3 would turn back into positive 12. All right, so be careful with your negatives there. Now we notice that we have a set of things in common, so we're going to write that once, x minus 3. We do not write squared, no, 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 no. Okay, even though there's 2 parentheses, it's just 1 parentheses for the things in common. 1 parentheses for everything not in common, so the x squared and the minus 4. Still equal to 0. Let's keep factoring if we can. X minus 3, x squared minus 4, perfect squares, x minus 2 and x plus 2. And there we go. We've got 3 solutions. That's what we should have. X is equal to 3. X is equal to plus or minus 2. All right, one problem for you to finish up here, problem 89, and that's it for 1.5b. Short one here today. Go ahead and wrap up 89, and any questions, we'll be sure to go over them in class. Good luck.